Good evening, everybody. Today we intend to discuss on a new variant of ferro-alloys, that is LCFC or MCFC, which is a niche ferro-alloys. Low carbon ferrochrome LCFC or microcarbon ferrochrome MCFC, the myths and methods for easy manufacturing. Amit Mukhopadhyay, niche ferro-alloys maker. It is a myth that LCFC or MCFC can be easily manufactured through the AOD, argon oxygen decarbonization converter process. First of all, we should understand what LCFC is and what its utilities are. As we know, whoever is associated with steel or ferroalloys industries, ferrochrome can be of three variants: high carbon ferrochrome, medium carbon ferrochrome, and low carbon ferrochrome. High carbon ferrochrome, the carbon content ranges from 4% to 8%. Medium carbon ferrochrome, carbon content is between 0.5 to 4%. Low carbon ferrochrome, carbon content is between 0.15 to 0.5%. Microcarbon ferrochrome, the carbon content ranges from 0.06 to 0.15%. Ferrochrome containing about 4 to 8% carbon can be used as a chromium additive for the alloy to iron and is especially popular to use in stainless steel because of its cost effectiveness. It is also used to make ball bearing steel and steel for auto parts. Steel makers usually prefer to use low priced material with a meticulous view that without increasing the mass of carbon, the lowest priced high carbon ferrochrome is also preferred. Ferrochrome with a carbon content of less than 2% carbon is suitable for making stainless steel because of less carbon burden, but the cost effectiveness is always to be reviewed, and it has been experienced that medium carbon ferrochrome effectiveness is low in comparison to high carbon ferrochrome. In the international market, there are very specific usage of different grades of low carbon ferrochrome. This table is self-explanatory. These are the preferred composition of what the customer wants. But interestingly, in the market, the bulk consumption of LCFC or MCFC are in the stainless steel industries, where recycled scrap melting are the main ingredients for ingot castings and foundry castings. Besides of stainless steel, welding electrodes is another area for LCFC. So the usage of LCFC are in the specialized areas, and its prices also considered to be much higher than normal ferrochrome high carbon. The most economical process to manufacture LCFC or MCFC is through EAF. The reason behind it is it's simple to operate and the metallurgical process steps are very few to follow. The ingredients are as follows: chrome ore concentrate. The size usually recommended are fines, but fines ore are usually received with high moisture level but with low gangue. It will be highly appreciated if the fines can be demoist up to 1 to 2% as H2O level, because once we charge the concentrate ore with high percentage of moisture along with lime, then lime can be easily react with water and form calcium hydroxide, which doesn't make a good impact on slag composition apart from increasing of slag volume. The compositional part we need to select very carefully. Have a look. If you prefer to make 60 chrome grade with 0.1% of carbon, then 37.5 to 38% will be Fe in the metal, which means 1.55 to 1.6% is the ratio of chrome and iron. Let's consider in the concentrate ore, the Cr2O3 is in the range of 54 to 56% and FeO is in the range of 15 to 16%. Then 4000 kg of chrome ore concentrate, 1900 kg of ferrosilicochrome and 3900 kg of lime should be added. Consider recoveries of chromium, then output of metal and approximate finished chemistry assumed. The table itself is self-explanatory. In case of chromium ore, concentrate receives in the range of 48 to 50% with FeO range 15 to 16%. Then, with different chromium recovery, the table is self-explanatory. Then the question arises, as if we could attain the percentage of chrome within the desired ranges with potential elemental recovery, why to buy a higher percentage of Cr2O3 enriched chrome concentrate? Look at the metallic output. The output of the metal increases, possibly with the same operating cost per ton. The metal weight increases except the ore concentrate prices. The price is not that much high in comparison to the finished metal prices. With low grade ore, the discipline in furnace operation should be of very high degrees, then every result of the output will be perfect plus. Ferrosilicochrome. This is a kind of ferro-alloy which is popularly used in manufacturing of LCFC or MCFC. But it is to be kept in mind that the percentage of carbon within ferrosilicochrome is a very important ingredient to be played in the latter stages. For example, if we intend to keep percentage of carbon in ferrosilicochrome in the 0.08 to 0.09 ranges, then the end result will be as follows. 1800 to 2000 kgs of ferrosilicochrome with 0.085% of carbon is equal to 1.61 kg. 4000 kgs of chrome ore concentrate will contribute 2.80 kgs of carbon, a total of 4.41 kg of carbon burden from the raw materials, with a 70 to 80% carbon recovery for a calculated output of 2800 kg to 2900 kg of metallic output. The percentage of carbon may reflect within the range of 0.09 to 0.10. So it is utterly most important to finish percentage of carbon within the ranges of 0.02 to 0.04 range in ferrosilicochrome as to finish the percentage of carbon in the finished product within the range of 0.07 to 0.09 ranges. It is because chrome ore concentrate is a product which is either purchased from the market as it is conditioned. The consumer may not have enough opportunity to do anything in the reduction of percentage of carbon. The slagless process of ferrosilicochrome in SAF, it is very much possible to finish the percentage of carbon within the desired ranges so that the finished product can have the least problems. Lime is another important ingredient in the manufacturing of LCFC or MCFC. The reason behind it is the silica and alumina. Both are highly deleterious for the EAF basic refractories. The composition and sizes are important for a better reactivity and effective slag composition. Once the smelting or melting process gets over, different qualities of lime are available in the market, but CaO more than 90%, SiO2 less than 2%, LOI and unburnt should be bare minimum. The reason behind it, lime followed an important role to form dicalcium silicate, tricalcium silicate, tricalcium aluminate, etc. Besides to form chrome oxide spinel, these compounds are refractory friendly and can be reduced once the metallic oxides are in contact with strong deoxidants. It has been experienced that a little percentage of MgO will become helpful in addressing low Cr2O3 percentage in the slag followed by higher elemental recovery. It signifies that little percentage of MgO will be helpful to maintain a desired slag kinetics as it is an EAF, so the slag will be always superheated than the metal, and slag composition as well as fluidity in conjunction with the temperature will have a great impact over the slag content of percentage of Cr2O3. As low will be the Cr2O3 in the slag, there will be possibilities of higher elemental recoveries. Still, for a better understanding, the ternary phase diagram will be helpful to understand what really the bath wants. The concept has taken as reference because of, we all know, the slag is a heterogeneous solution and its kinetics, that is composition, fluidity and temperature, are the critical factors to maintain the conductivity of the slag so that an optimized percentage of Cr2O3 can be obtained. To saturate the slag, ideally we need a very high percentage of CO, and the slag with high percentage of CO may not bear enough fluidity to capture the desired percentage of Cr2O3. So it is predominantly important to make the slag fluid enough so that capturing of Cr2O3 can be possible with even high temperature. The slag finishes percentage of MgO at the range of X, which comes from mineral and lime itself. So for the sake of proper conditioning of the slag, need to put MgO. The Chinese have not spoken much about slag because of so many reasons. Out of them, their own lime kiln, followed by less percentage of powder, helps to form a highly fluid slag with high reactivity and conductivity. We import lime either from overseas, and a long retention period right from manufacturing to usages may become the root causes for high percentage of powder generation in lime. Still, we need to condition the slag by increasing percentage of MgO, and the overall slag basicity can be increased. In my opinion, a little percentage of MgO in the slag can improve the overall behavior of the metallic output and the furnace refractory consumption. Hope this information will bear easier process tricks by which the LCFC or MCFC manufacturing through EAF will be smooth and perfect. My experience found that process metallurgy plays an important role to obtain a good output and optimized cost per ton. Thank you very much for your time and patience to listen. If you have any question, kindly ask in comment section.